So again, I'm saying, if you want to find out the electrode potential of the individual half cells, we have to use the help of the standard hydrogen electrode, right? So standard hydrogen electrode will be having an arbitrary electrode potential of 0, right? Isn't it? Now moving on to this, now we have to see that when we take the standard hydrogen electrode, right? We are taking the standard hydrogen electrode. Why? Because we want to we want to find out the electrode potential of cells, right? What is the electrode potential of the cells, right? Isn't it? See, now if you see, when we talk about any cell, suppose I'm taking different cells, I'm connecting it to the cathode. Please note down this part, right? This bit, right? And I'm connecting the hydrogen electrode to the anode, right? Now, Tiara, what is a hydrogen What is the standard? Sorry, can you tell me what's the electrode potential of the standard hydrogen electrode?
0.
0. Brilliant answer, right? So we know that if you connect these, right, we have to have a oxidation reduction happening, right? Without that, the cell won't work, isn't it? So we learned that if we connect these two, whatever voltage is giving out over here, this is what? This is the E dot cell, right? E dot cell will be equal to what? E right hand side cell minus E left hand side cell electrode potential. Now, if you see that the E right hand side will be this cell which will there, right? Isn't it? E right hand side cell. Left hand side cell will be 0 as Tira said. What we are getting? E dot cell will be equal to actually E right hand side, right? Right? Is it clear? Do you get my point? So whatever value you are getting over here, this is actually this electrode potential. Isn't it wonderful, right? The scientists who have done this, I'm just saluting the scientists, right? What brilliant idea. Richard, did you get my point? This thing is clear to you? What happening over here? Clear, Richard? Fine. That we are taking what? We are taking the two half cells, we are connecting it. And what happened? Whatever voltage we are getting over here, right? That will be actually the electrode potential of this half cell, right? Isn't it? Isn't it? Because this is 0. Now, see, we are connecting the individual half cells one by one. We are getting these value, right? Isn't it? We are connecting these and we're getting the values, right? One by one, right? This. Now, now we have to know a very important trick over here. You can note down this trick. G is equal to minus NFE, right? Write down this part, right? Isn't it? Clear? Right over here, G is equal to minus NFE, right? Clear? Now, for a spontaneous reaction, please take out your Zoom chat and send me for a spot. This thing is not in the book, right? This thing you have to use now. That will be very easy for you. Now, see, we are getting the we are taking all these cells where at the cathode, right? So all the reduction reactions are there. Can you see this? All our reduction reactions we're getting, right? So technically, all our reduction potential we're getting, right? But can you tell me that if we take suppose zinc and nickel cell half cells to make a cell to generate electricity, which cell to take at the cathode, which cell to take at the anode? We have to take the help of this equation. That will be easily solving you. Now take a Zoom chat and write it to me. G should be what? G should be negative for a spontaneous reaction or a non or positive for a reaction, spontaneous reaction. If the reaction is spontaneous, G should be positive or negative, right? I just told everybody yes. Everybody, right? Negative, right? It should be negative, right? If G should be negative, right? First tell me if G is negative, the E should be what? Now tell me one thing. Is it clear? E should be what? For a spontaneous reduction happening, for a spontaneous reduction, this reaction, which is more spontaneous? If the E reduction potential is negative or positive? Because see, there's a negative over here, right? Just see the answer, what I'm getting. Mm-hmm. Snigdha, sorry. Can you quickly guide me, Tiara? That if this is negative, right? What should the sign of the E? Can you tell me? Positive, right? Isn't it? Positive into
Positive.
negative gives you what? Negative. Understood. Good that you're doing this chapter, right? Is it clear? Richard, is it clear? So E should be positive. More positive, more is the spontaneous reaction. Now, having applied this trick in this, right? This bit, that E should be positive, right? To make the overall cell negative, means spontaneous, right? Sorry, the electrode potential, right? Should be positive, more positive. Now, if you take these two cells, right? You have given these two data. In your exam also, you'll be getting this, right? If you're taking these two data, right? Look at, tell me that which one to the cathode and which one to the anode. We have to use this formula, G is equal to minus NFE. So from here, we have to take that cell which is more positive, isn't it? More positive reduction potential. That will be going to the cathode. Everybody is clear of this? So if you take zinc and nickel, we will take that cell which is having a more, tell me, more more positive reduction potential, right? Clear? Positive is what? Zinc, sorry, nickel, right? So nickel we have to take at the cathode and say this is more negative, right? Or less positive. So this won't suffer reduction. This we have to take at the anode. Anode, what reaction happens? I've got a red cat in my house, so anode will be oxidation. So to flip this reaction, we have to flip this and flip the sign also, right? Zinc goes to zinc 2 plus plus 2e, right? We are getting this, right? Is it clear, everybody? And we flip this sign also, right? So in this part, what do we do? In this part, we are taking two half cells, right? We are taking two half cells, and we are selecting that which one to the cathode by what? More positive reduction potential. This. So we write down this reaction as is, right? We have to flip this reaction because this takes the anode, right? So this is the thing we are getting, right? Is it clear? And we have flipped this sign also. Now we have to add these two reactions up, right? When you add these two reactions, what we have to note, see, this is a very important point of discussing. Please check that the electrons should be same over here, because electrons is not destroyed or created, right? They're transferred from one process to other. Please check that the electrons should be the same over here, right? Isn't it? Fine. Is it clear? Fine. Now, having said this, if you see that when we add, what happens? This gets cancelled out, and we're getting the total reaction as this, right? This is a total cell reaction which is happening, right? Now, guys, you have to quickly understand a very important part in your question paper, in your exam. They also will be asking you that what is the direction of the current, isn't it? Right? What's the direction of the current? That's a very important portion or important bit you have to master. What's the direction of the current? Now, remember one thing: at the anode, the electron is released, right? Isn't it? Fine. Electron is released. So the electrons will be moving via the anode to the cathode via the external wire. Please note down. This is a very basic question which comes in a board, right? What happens? The electrons will be moving from where? Moving from the anode to the cathode, right? Just write down this. Any cell, electrolytic cell or or the voltaic cell. The electrons go from where to where? The electrons go from the anode to the cathode, right? Clear? Understand this part? Electrode goes from the anode to the cathode, right? Clear? Clear? The electrodes will be moving from the anode to the cathode. That's the thing you have to understand, right? Clear? Thank you so much. Now we're going to move on to the next part, right? Okay. See, this is the example I'm telling you, right? See. Now over here, quickly tell me, please take the Zoom chat and tell me which cell you have to take at the cathode, which you take the anode. What did I tell you? I told you the trick that delta G, sorry, G is equal to minus NFE. So G should be negative, right? From these two, these are reduction reaction. The more positive the electrode potential, more spontaneous with it, right? More positive, right? So can you tell me which of these two cells will take at the cathode? Quickly tell me. Write down Fe or zinc, Fe or Zn. Okay. Very good. Very good. Understood. Very good. Everybody fine, right? So we're seeing over here, this is more positive, right? So this will take at the cathode, and this is the anode. But anode, what kind of reactions happen? Oxidation happens. So to flip this reaction, guys, right? Flip the sign also, right? Clear, everybody? To flip the sign also, right? So that gives you what? That gives you the portion over here, right? But we are seeing what over here? That we are flipping the sign, right? We are flipping the sign and we're getting it, right? And over here, can you think of this part which I told you just? Finally, to check the electrons. See, the electrons is not same. If the electrons is not same, what do? You multiply this by 2. Is it clear? Don't multiply the electrode potential. Now you can write down also that electrode potential does not depend, right? It does not depend upon the electrons, right? Isn't it? Understood? Number of electrons it does not depend upon, right? Can you think of that? Recall that part. I just did this part bit. I just did this part. Wait. This part I did, no? Can you recall hydrogen standard hydrogen electrode? I told you that this you can also write this reaction as 1H plus 1E gives you half H2, but the electrode potential won't change, right? Clear, everybody? Now I'm just quickly moving on to the part of the oxidizing agent and reducing. See, this bit you have to know also, flow of the electrons. This is a very common question of your boards. So got it? Is it clear to you? So this is very important, that if you connect these two, right, we can easily predict, right? Fine. Now, next question, that if you see that in the electrochemical series, right, in the electrochemical series, right, now over here, can you tell me that which is as we go from bottom to the top, right? This, right? You're seeing what the negative value increases. Can you see this? The negative value increases, right? As we move from the bottom to the top, what happens? The negative value increases, right? Is it clear? The negative value increases, we are seeing, right? So if the negative value increases, right, now what does it tell you? That is it more susceptible to suffer oxidation or reduction? Please try to type out. We're going from the bottom to the top, right? So the positive value decreases and the negative value. So is it more powerful oxidation that will be happening for that species, or reduction that will be happening, right? Tiara, understood the question? Huh? Tiara, understood the question, what I'm asking
Yeah.
you? If I'm going from the bottom to the top, the oxidation power increases or the reduction power increases? What do you think? Use this formula, G is equal to minus NFE. Straight away, you'll get the answer. See, this is more negative, right? As we go from bottom to top, the oxidation power increases. Right? Everybody clear? Wonderful. No, oxidation. See, this is minus, right? So this is positive, right? Means what? As we go from the bottom to the top, what happens? The reduction capacity decreases, isn't it? See, reduction, all the reduction reaction, right? So we have to flip it, right? So oxidation capacity increases, right? So as you go from the bottom to the top, what happens? It becomes a powerful reducing agent. Clear, everybody? Strongest reducing agent, right? Now, if you go from the top to the bottom, this is a star question which has been asked in a boards, right? You go from top to bottom, what happens over here? If you go from the top to bottom, the positive value increases. Means what? G is equal to minus NFE. The positive value increases, right? Means what? The spontaneity of a reduction increases. So they will be powerful in reduction. Means they will be behaving as a strong OA, right? I told you in opposite, right? The gain of electron reduction, OA, oxidizing agent, right? Do you get my point over here, right? So it's a very important point we have to understand, right? Fine. Thank you so much. Thank you so much. Thank you so much. Yes, Richard. Richard, is it clear to you? Do you get do you answer? But always use this formula which is not in the book. It's from my trick. I'm telling you. G is equal to minus NF. You can these are reduction reactions. See, so more positive, negative into positive is negative. So more positive, more reduction means they will be behaving as a oxidizing agent, strongest, right? Any species suffers reduction, behaves as the oxidizing agent, right? Clear, everybody? Just open the videos I'm sending you, right? I'm just telling you that just open the videos, stop and play, go through it today, right? So that bit we have to know, right? Now, I'm just going straight to the book now. So we have covered the important chapters. We have covered 3 chapters. Now I'm going to the individual cells over there, right? Just 1 minute. This is page number this. Wait, hang on just 1 minute. Everybody has done the curly arrows. Have you done the curly arrows part? Huh? Tira, did you do the curly arrows, Tira?
Yeah.
Curly arrows you did, right? Fine. Okay. Just go through my mind map which I sent to you earlier, right? So 302. See, we did this, right? We did this. Huh. Solbridge, we take what? Solbridge, we are taking this because to make the connectivity, right? Because between the two cells, right? Isn't it? So we have gone too much deeper. See the standard hydrogen electrode we are taking, right? The difference between the things, right? We did, right? Isn't it? So this will be giving, see, half reaction given you to pick up, right? No, I'm just asking you a random question. See, I'm taking this cell, I'm taking this cell, and I'm taking this cell, right? Now, can anybody tell me that, just message me that which one to take at the anode now? Tell me, anode. Which cell to take at the anode? Aluminum or zinc? Quickly tell me. And Snee, please open your topic-wise past paper, right? Thank you. I'll be going to... at the anode, which should take an anode? Tira, first tell me, I'm making the question easier for you. Which one take the cathode? Tell me. Cathode, you to take what? We to take, yes, zinc. Cathode zinc, because it's more positive, right? Isn't it more positive, right? Use this equation, G is equal to minus NFE. Just think that why? Because what reactions is given over here? Reduction potential, right? See, in the book, it is not written why are reduction potential given, right? Just remember that I've told you the trick that we, while measuring, we are always taking that in the cathode, right? Intentionally, forcefully. Whatever voltage we are getting, we are writing over here, right? Isn't it? Whatever voltage we are getting, right? Taking the hydrogen cells, right? Clear? Now, we are going to the last bit of it, the individual cells which are